Hello, scholars, and welcome. Hello, statistical scholars, and welcome to a Minitab 17 episode of Well, Let's Do Some Statistics. I am going to be talking today about the Chapter 4 Minitab Day Notes, which you can find in your Minitab folder, and you will see opened here. I also have the loan application data that it mentions opened on the left side of your screen in Minitab 17. And in this description that you see in the Word document that goes along with this data, you have all the metadata or the description of what our data is in here. So I'm hoping you notice that we have several quantitative variables present in this data set. The age of the applicant, which is in years, the income that they have, how many years they've been employed, their savings, the amount of debt they have, and their credit cards, so the number of credit cards that they have. I would say that this is a good data set for us to practice some quantitative analysis on because it's a lot of quantitative variables. So the first thing we're going to do is we're going to create a scatter plot of the income and savings variable. So in particular, I say that you should be using the income variable as the explanatory variable or predictor variable. You can think of this as like an x variable, an independent variable. And then we're going to try to use that to predict the response variable savings. So someone's income to predict how much they're going to save. And then we're going to describe the association we see in terms of the 4 things that you should look at as far as describing association. So let's make that. So like all of our other visual describers of data, it's located under graph. So let's go, oh, there's scatterplot. It's the first one. I almost skipped over it. There you go. So there it is, and it's going to pop open a menu. We're just going to do a simple one this time. I'm looking to look at what the picture looks like, and I don't need any of this extra descriptors or extra lines or anything like that to see what that looks like. So I'm going to go ahead and hit OK. And then for the Y variable, or the response variable, I'm putting in savings. And then for my X variable, or my explanatory variable, I'm going to be putting in an income. There are other things that I can select within these data options, like the scale, multiple graphs, other things like that. I'm not going to mess with any of that right now because I just want a simple picture of what's going on. The other thing you'll notice is that there's lots of graphs this can make. So if you're going to do multiple scatter plots at the same time, you can put in lots and lots and lots of graphs and it'll produce lots of graphs for you. So you can put in multiple Y's with different X's or multiple X's with different Y's. You can put lots of stuff in here and create lots of graphs all at once, which is kind of nice if you're going to do multiple problems or look at multiple value options. Alrighty, so there's our scatter plot. So I'm I'm going to right click in the gray space to bring up the option to copy the graph over to my Word document, and then I'm going to describe the FODs, or form, outliers, direction, and strength. So I like to do form first. I ask myself, does this relatively look linear in shape? I think this does. So I'm going to go ahead and call it linear. It's fairly linear. Woohoo. Non-linear would happen if it has any curvature or wave shape or maybe a V or change in direction anywhere. This generally seems to be, going into a fairly straight line. So I say this is linear. It also looks like it's positive to me, so that's my direction. So as my X values, my explanatory variables increase, I have to go upward to touch points that are up here above. And so therefore my Y values or my response is also increasing. So as my X increases, my Y increases. As my explanatory increases, my response increases. This is indicative of a positive relationship since they both move in the positive direction to move along each other. So this looks positive to me. Alrighty. The next thing I want to describe, so I've got my F, I've got my D, I've got my form, I've got my direction. I want to look at outliers next. So some of you are going to say this point looks like it's an outlier. When you describe outliers, they have to be something that's off form. So if I were to try to describe this with a line, I might draw it maybe right here. And notice that line would be close to that point. To be off form, it must be not only really away from all the other points, because this guy does kind of seem like he's off on his own, but it has to be away from the typical direction. So it would be like somebody who would be down here. So if I left my mouse there, somebody who makes $90,000 a year, but only saves $300 a year or something like that. Something that appears to not be like what the rest of this data appears to be. So I would say this has no outliers. All right, I got my F, I got my direction, D, I got my O. I'm not spelling this correctly, outliers. And And now I need my strength. This is reasonably tight. It's not got a lot of scatter. Remember, strength is all about how it scatters away from the form. So if it looks linear, how much do my points seem to move away in each direction from being linear? This doesn't have a whole lot of scatter, so I'm going to go ahead and call this a moderate. But it's actually a pretty strong moderate, so if you would call this strong, that would be okay. It's probably strong. That'd be my luck. I call it a moderate on a day that's a strong. Okay, so those are how you visually describe this data. So we've done past visual descriptions in our different variable relationships. So after we do the visual version of this, let's go ahead and do the numerical. Let's find a number that describes how these two are related, and that number is correlation. So to find correlation in Minitab, we go to Stat, Basic Statistics, and then you'll notice, oh, sorry, my mouse jumped. Near the bottom, there's correlation. So I can go ahead and click on that. And I'm going to put in income and savings. Oh, not debt. Sorry about that. Get rid of that guy. Wrong variable. I'm just double clicking to get this in. I'm also going to unclick p-values. You don't really need that for this part at all, or anything we're going to do with this. So, I'm just going to unclick it so there's not any extraneous information I don't need. I'm going to go ahead and hit OK. And there's my correlation for the two of them. This is the Pearson correlation, in case you were wondering. There's other ones out there besides it, but that's the one that we are using in this class to describe the strength of linear relationship between these two data points. And there's two things to notice about it. It is close to 1, aka it's far from 0, so that means this is pretty strong. The other thing is that it's positive, which is indicative of direction. So since positive direction, positive correlation value. So there you go. It could also have been negative if we saw a negative direction and still been considered strong. So don't think, positive is the only way to be strong. This could have been negative 0.874 and still been strong. It's just the negative accounts for direction. So when you're thinking about Pearson correlation, it really tells you two things: strength and direction. Watch out for that. All right. Now let's calculate a bunch of correlations. So it turns out you can produce a table of multiple values. So if you weren't sure which of these variables were best related to each other and which one you might want to make a line for, you could throw them all in together and make it calculate all the correlations for you. And I'm going to do that now. So I'm going to go back to Stat, Basic Statistics, and down to Correlation. And I've already got income and savings in there. Who else do I need? I need age and debt and number of credit cards. Do I got all of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, we're good. And I'm going to go ahead and hit OK. And it's going to produce this matrix that can be kind of hard to read if you've never seen it before. So I'm going to copy it over here. Oh, that was good. I'm going to undo that because that's not very good. So I'm going to do a little trick that I've learned, is that if you right click in Word, it'll give you options on how to paste stuff. So I'm going to choose, right now it wants to merge the list. I don't want to merge, I just want it to stay like its standard values, like it looks before. Okay, so now you can see debt. All right, so if you look at this number down here, that's representing the correlation between debt and credit cards. Here's the one for age and credit cards. Here's the one for age and debt. Here's the one for savings and age. You'll notice that this upper triangle isn't filled with anything because the correlation between savings and itself, well, that would be 1, because anything correlated with itself, how is it related? Well, they're the same. Of course they're related. But you might be wondering, well, why isn't age and savings in here? Well, I just pointed that out to you. Age and savings is already in here. It's right there. So it doesn't offer the extra ones you don't need. So if you wanted to know, the correlation R value for all these, you could look at it that way. The other thing you can ask yourself is, which is the strongest relationship here? Okay, which, is the same as asking you, hey, who's the farthest from 0? Well, that would be income right there. And then you might ask yourself, well, who's the weakest relationship? That's the closest to 0, which in this case would be 0.14. And I'm looking at these regardless of sign. Sign just indicates direction. So for strength, we look at how large is the value, or how, if you want to look for weak or how small is the value. Alrighty, now let's look at how much of the variation of savings can be explained by credit cards. Now, variation is described between two variables as r squared. It's also called the ratio of the ratio of variation, or the coefficient of determination. So what I really need to calculate here is r squared. And this is not a misnomer. R squared, although it tells you something different from r, sorry, I'm trying to make this not correct. Oh, there. Undo automatic. Okay, so although they're calculated by, how do I find r squared? Well, I square r. Not kidding. This is should be easy. So where's the R for savings and credit cards? Uh-oh, savings, credit card. It's not there. Let's look down the credit card ones. Credit card, savings, right there it is. So I got a square, negative 0.413. All right, now I need a calculator. While I do that, so what I was saying is that they describe different things, but they very much are related by, I just take one and square the other. So I need 0.413, and then I gotta square it. If you're wondering why I'm not bothering with the negative, well, you know, negative times negative is positive, so that's the same thing. I'm just gonna write everything in here. 0.69. Cool. So if I were to describe this, I would say about 17.06% of the variation seen in savings is explained by its linear relationship. Wrong, it's not, it is. With credit, the number of credit cards a person has. So as you look at this, that's what it's telling us. So the other thing you should notice is that's not a whole lot explained by credit cards. So, you know, if I'm looking for pointing towards savings, number of credit cards somebody has doesn't seem to do a great job. This is regardless of sign, negative or positive. So as you're looking at this value, you should be thinking, wow, credit cards is enough. Clearly, I need something else. And when you go to stats 2, you'll do multiple linear regression. You'll add in extra variables to account for what you're missing until you get a great job of explaining as much as you can. But as you can see, credit cards don't do that great of a job. Oh well, too bad. That's exactly why when we go to create our line of best fit, we are going to not be using credit cards to do so. We are going to be using income to predict our savings. So let's create a line of best fit, or aka do a linear regression. In Minitab, there are a lot of different ways you can create a linear regression. I'm going to show you my favorite one first. You don't have to necessarily do it this way. There are other ways, but this is probably the quickest one and the simplest one. Let me move this back over. Oh no, wait, it was Word I moved over. Get out of my way. I need more room for my Minitabs. All right. So we're going to go up to Stat, Regression, and I'm going to be using Fitted Line Plot for now. This is probably my favorite one. If you're just looking to create a line of best fit, it's probably the fastest. So first thing it's going to ask you for is your response, your Y value. And for us, that is going to be savings. And then our predictor that we're going to use, oh, I didn't get it. There we go. The predictor I'm going to be using is income. Now, there are other options in here that you can take a look at, but for now, I'm just creating a line fit. I don't really care about the rest of this. I'm just going to use its defaults as is to get what I need. So I'm going to hit OK. It's going to produce a couple things for me. There's a couple things you can look at inside of here. It creates this fitted line plot, which is nice. It's a good graphic of what your line looks like. This gives you S, which don't worry about that. Sorry, I forgot we don't do S. It's also giving us our R squared and our R squared adjusted. Don't worry about what R squared adjusted is. You don't need to know that for now. But up above, it also gives you your line. Savings equals negative $7,828 plus a slope times income. That slope is 0.257, which means for every dollar I save, I should expect to, for every dollar more I earn in income, I should expect to save about 28 cents. So there you go. That's how much you should be saving per dollar if this line were how you decided to live your life. Shrinky-doo. This gives you a lot of output in the session window as well. The first one being the most important, and that is the regression line equation, which I'm going to copy over here because that's what I need. Oh, I don't need the title of it though. I just need that guy. Copy and paste away. And it numbered it for fun. Thank you, Word. You're really screwing me up today. So that's my equation. Done. All right. Next up, I'm going to be using the equation for the line of best fit to predict savings and store the residuals in fits. Fits is just a fancy Minitab word for the predicted values. So if I took all of my income variable values, these guys, and shoved them into my line, what the result would be for a prediction for savings would be the fits, the predictors. Let's make those. So if we go back to graph regression and then fitted line plot, we can find this option within the storage key. So I'm going to hit that now. And then it asks you, hey, would you like some of this stuff? And I'm like, heck yeah, I want some residuals and some fits, because that's what I'm asked for in this question. So I can go ahead and hit OK. At the same time, I'm also going to do number 7. It says, hey, graph the residuals and then evaluate them, just so I don't have to go through this menu a second time. How you get graphs of residuals is you hit the graphs key. And then it asks you, hey, would you like some residuals? I'm going to do the 4 in one. You don't have to do all 4. The ones you really should be paying attention to, I will tell you in a minute. So let's go ahead and hit OK. And then hit OK again. It's going to produce lots of stuff for us. I'm going to shrink this graph for a minute because I don't need it. What I want to see is that, I'm going to have to pull this over so you can see it. It's created these values, Resi1 and Fits1. So Resi1 is your residuals, Fits1 is your fits. So what this is saying is that if I take this equation that I just found and I plug in, let's just look at this first row. Yeah. So if I plugged into this equation an income of $50,000, I would get this value out of my line. That's saying that I predict the savings for somebody who makes $50,000 should be $5,956. Cool. And if I take that one, if I take that one step further, I can say, what's the difference between what I predicted and what reality is? What's the actual value? So the actual value is over here in the savings column. Hey, the person who had $50,000 saved $5,000 a year. Okay, that's great. But my line was too big. It overpredicted it. So I actually can look at their difference and say, what is that? That's the residual, how far off we are from the truth. It's called an error, but again, errors in statistics aren't the same thing. It's how far your prediction was off from the actual values. So as you look at my residual, I was about $955.95 off. And the other thing to note about that is it's negative, which means you over-predicted. Uh-oh. Darn. Good to know, though. Cool. I'm going to move this back over. And then I'm going to pull up my 4 in 1 plot. If you ever lose a graph, here's the way to get it. You hit the Windows key and you'll see a lovely list of things. I want the residual plot. All right, so there are a couple things we want to be looking at here. I usually use just these first two to look at my residuals and evaluate whether or not they have done a good job. Oh no, I didn't mean to do that. Sorry. I'm doing all kinds of clicking everywhere but where I should be today. Pasty poo. I don't need to merge it. Oh, come on. The paste button doesn't like me today either. Okay, so the first one you look at is the normal probability plot. And what we want to see here is we want to see the dots close to the line. You'll notice that as you get up above 90, the 90th percentile or the 90% mark, you start to get away from the line. The same thing is true right about here. So right about at like 5%, it looks like I'm a little off too. So this is fine. It's pretty much normal, but there are a couple places where it's not. So we want to note we have non-normality, so it's not normal looking. Above, oops, the 90th percentile. And below, about the 5th. And it's a little higher than that. I'm going to call it the 6th. So I'm getting some non-normality there. It's not enough non-normality for this to fail or for you to not have something that's a good model. So that looks okay. The other thing you can do is you can look at the histogram and kind of see that too. So to be nearly normal, it just needs to have, you know, a nice sort of symmetric, peaky feel to it. This has got some outliers, so it's not too surprising that we're seeing that up here. Okay, now R versus fits is horrible looking. Oh no, why do I say it's horrible looking? Because it has narrowing and widenings to it. This should look like a sneeze. It should have no pattern whatsoever. It should look totally random. If it has any pattern at all, it should look linear. This to me looks like a big old curvy U fan. It has a fan shape, and that's bad. That means that somewhere I'm missing something, or I'm missing a nonlinear relationship when I was evaluating this. So our versus fit graph, sorry, has a fan shape, which indicates some nonlinear relationship. That's bad. We want to see some randomness to this, and it's got some randomness, but it's so narrow right here and then wider over here. Usually what this indicates is that you were tight and good for smaller values, but then it got bad as you got into the larger values. This is sort of indicative of what's happening over here where we're starting to get far away. above the 90th percentile. Um, so what you really see here is it almost looks like you would have been better off modeling this with two lines, one for smaller values and one for larger values. Okay, because the non-normality, it didn't seem to indicate any problems. All right, so there's our residual plots for now. I hope you enjoyed it. If you have any questions, don't be